necessity is the mother of invention. And if you want to do something bad enough, you'll think of a way to do it. I have a tower out in the backyard, and I'm way too old to climb it. So how do I get a dipole up there without ever leaving the ground? Stick around. I'll show you exactly what I did. W1VLF. Hey everybody, my name is Paul, W1VLF, and welcome back to the lab. Today we're going to be outside, and I gotta apologize right up front. There's some really shaky camera work going on here. But like I said in the introduction, when you're a one-man operation, it gets a little bit tough. But I think after I show you the demo in here and then we go outside, you'll understand. Hopefully it'll be clear enough so that you'll be able to understand how I did this and what I was trying to accomplish. And there'll actually be a couple of facts and figures. So the first thing we're going to talk about is dipole, right? 2 insulators. The choke to keep the RF from coming backwards down your coax. 40 meters. That means this is 66 feet long. I may not tune up right where I wanted, but I made it 66 feet long just so that you'd have a number, relatively close. So that's the dipole we're going to pull up without our little feet ever leaving the ground. Let me throw that off. The other thing we're going to need is some rope, 2 pieces. And we're going to need 4 pulleys. I only have 2 pulleys here, but I'll zoom in on these and show you what's going to happen. These could be clothesline pulleys. These happen to be pulleys that I have from an old exercise machine, and I said, you know what, I can't throw these pulleys away. These are too good for something. So when the machine was getting torn down, I grabbed a hold of these pulleys. This piece is galvanized. In my case, I'd suggest making sure that you use some stainless hardware here, but you can also use clothesline pulleys, which will last, and I've used those too. I did this little experiment is something I've done, I don't know, 10 or 15 times over the past couple of years, but I never really explained it or told anybody about it. So here's what I'm going to do. I'm sure I'm not the first one to come up with this idea. I never researched it, so I don't know. Maybe I am, maybe I'm not. Anyway, so we have the rope, the pulleys, and I'm going to get my tower and put it right up here on the table. So let me set up for that shot and I'll be right back. Okay, so here is the stand-in for my tower. What really matters here is the thing has 3 legs equally spaced in a circle. And we're talking about my tower obviously goes right to the ground, but this one doesn't. But for the most part, we don't even care about this piece in the middle. Well, there's a few things that we care about. We care about the overall height of this, because the higher this tower is, the farther we'll be able to pull the dipole up. But here's some dimensions. Now, I went through a ton of math trying to figure this out. My wife and I went through this, right triangles and forming this and that, and I finally said, you know what? Somebody out there smarter than me can figure out the math on this. I'll give you the dimensions of what actually happened, and maybe somebody else out there can figure out the math, a formula for folks to be able to figure this out on their own. I did it empirically, like I do a lot of things. So here's what we know. We know that this point here, where the guy wires connect, is 120 feet above the ground. Okay. We also know that this is guyed at about what's called an 80% ratio. So the guide points are approximately 80% out. In my case, they're around between 96 and 100 feet out, each one of these guide points. So between that being vertical, you can figure out the length of this is 150 something feet, I think. the hypotenuse of this triangle. So here's the important pieces. The important piece is that from the tower out to, I hope you can see this. Can you see this? Yes. From the tower out to this point, from the center of the tower out to the guy wires, is 100 feet. The other thing that's important is this. Between the two guy wires, the two anchor points, is 185 feet. Okay? So that means that from the ground to here is 185 feet. If we start to go up this triangle, let me do that from the back. If we start to go up this triangle, they're getting closer together, closer, 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 until they come up to a point here. So the question is, if you have a dipole that's 66 feet in length, I don't know, let's just use this as 66 feet. Obviously, you could mount that dipole, well, you couldn't mount it here, but you could mount it here. And I don't know what that dimension is, although I've pulled up many dipoles on this tower. That's why I'm giving you the fact that this is a 40-meter dipole at 66 feet. So how are we going to do that? Well, let me zoom into these pulleys a little bit more, and I'll show you how that's done. Okay, so this is what our pulley arrangement is going to look like. You're going to have essentially a 8 pattern here. If I could ever get this in there. Okay. And this one. Wow, sucks to be old. Alright, so I have these connected together with a magnet. You would be tying them together with a rope. So kind of looks like one of those things you have on your clothesline to keep the wires from separating too much. But here's the key thing that's going to happen is, what we're going to do is, and only one of these has to have a pin in it that you can pull out. But you pull that pin out, it's up to you guys to figure out, what pulleys to use. And then you slide it back in here. Whoop, figures. Okay. Watch. Slide it back in. And now what you have is a pulley that will ride up and down on the guy wire. Well, that's great. Alright, so now what you do is you take your rope coming from your dipole and go over the top of this pulley. Okay, hope this will stay together because I only have it tied together with a magnet. And let me move out of the way. As you pull towards the tower, that pulley will ride up and down. Okay? And you do the same exact thing on the other leg over here. Okay? Move this over. Maybe you can see it. I don't know. It's getting a little topsy-turvy here. But you do the same thing on this side. Okay? So it rides up. So your dipole, let me get this out of here now, will end up in the middle of the triangle here. Somewhere in the middle of these two legs. Let me zoom out a little bit. Okay, so a very long dipole, let's say this is the length of the dipole. I told you this is 185 feet. This wouldn't come off the ground at all. But a 120-foot dipole, say on 75 meters, shorter, might go up this high. And a 40-foot dipole with the two pulleys could be pulled up this high. And 20 meters probably up here somewhere. So it all depends on how well, how far apart your guy wires are, and that this whole thing, this isn't really a great way to show it, but it's the only way I have here. Okay? So your dipole would be in the middle here. It's not really to scale either. So anyway, and so by pulling on the two ropes and the two sets of pulleys, maybe a better way to do it would look like this. Okay? When you pull on both of those ropes, these two pulleys ride up. and they'll go up as high as this one's not spread out far enough. This one, just one second. Well, anyway, they will go all the way, go all the way up as high as they can. Whoops, they're in like this. Excuse me. What am I doing here? No, they're like this. You have the two more pulleys on the inside. Sorry about this. This is really one of the hardest videos I've ever had to do to demonstrate things. But you understand, there's another pulley here, another pulley here. And when you pull on those ropes, those pulleys ride up the tower leg. Excuse me, the guy wire. So that's about all that I can really demonstrate in here. Again, the dimensions are, it's 185 feet between the legs. It's 100 feet from the center of the tower to here. And it's a 40-meter dipole that's 66 feet that's going to end up in between these legs. Now, if you pull it all the way up so that the insulators are touching these legs, there's definitely going to have some interaction between the metal and the tower and guys. But for a quick, couple-hour experiment to pull a dipole up and see if it works, and then lower it down. The other thing about this, everybody's talking about these days about NVIS, right? Near vertical incident. Skywave. A 40-meter dipole down here, say 30 feet above the ground, 40 feet above the ground, 50 feet above the ground, 60 feet above the ground. You could experiment with that. The other thing that you could do is you could pull a rope, just using a rope, up as high as you want. Can you see that? Yeah, you can see that. And then hang a vertical dipole down. So with this method, it seems a little clunky, but it works really well. So if you think this camera work was bad, wait till you see the rest of it. But the idea is sound, and I've done it for years and years, and I have dipoles up for 10 years like this on my tower. All right, so I guess I'll go over and edit the rest of that video too. Hey everybody. Okay, we're outside at the tower. We're close to it. Take a walk up. And on the ground over here we have a 40-meter dipole, 66 feet long. Okay. It's nothing special there. There's the tower. And I hope that focused. That's the top of the tower. Top of the tower guy wires are 120 feet up. From the base of the tower, I guess I gotta zoom in. Oh yeah. To the guy point is 100 feet. And I'll try to go slowly. The point between this guy wire and, I guess it's in the picture. I can't really tell. It's so bright in that direction. The other guy wire there is 185 feet. So what we're going to do is, after we get this hooked up and like using the pulleys like I showed you before, we're going to go out to one of the guy wires, thread stuff through, and I'll show you how to pull this 40-meter dipole up as far as I can pull it up on my tower. But your feet will never have to leave the ground. So let me head out there, because we're burning daylight, to the guy anchor point. Okay, so we're out at the anchor point here, and I'll give you a quick look at that. The anchor point is this particular anchor point, because there's 2 of them per side, so there's actually 6 anchor points. But this one is, this is the one that's 100 feet from the tower. My tower is 120 feet tall, and it's guyed at what they typically refer to as 80%, so it's roughly 100 feet to where that goes in the ground. There's an equalizer plate, and each one of the guy wires is actually 2 guy wires that go up to the torsion triangles up on top. They're not torsion bars, they're torsion triangles, which are quite a bit more effective. Anyway, let's see if I can get this over to where the pulleys are a little bit more. Okay, so there's the pulleys. I hope this is I'm gonna zoom in on those pulleys and then come back and zoom out. But here are the 2 pulleys right in the middle of the page, or right in the middle of the screen. And I'm going to go kind of roll them back and forth and show you what's going on here. I think I'll pull back a little bit because sure in heck I'm going to miss something. All right, so now we're out at the two pulleys. And these are old pulleys from a barbell set. Not the best, but you know, they work. You can see how this wants to ride up and down the guy wire. So what I'm going to do, and there's two of them, they're tied together, no problem, right? There's probably a lot of extra rope on here. These have been hanging here for probably 10 years now, since the last time I did this. And you pass one of the ropes connected to the end of your dipole through this. Okay, so now what you have is, I don't know if you can see this or not, but as you pull on this rope, it's going to start riding up the guy wire. Let me cut back a little bit and show you that up a little better. Okay, I'm just going to do it a little bit here, and then these are really hard shots to do. I don't know what you're focusing on here or anything. Okay, but you can see the pulley here, the other pulley, and as you start pulling, it'll start walking its way up the guy wire. Okay, and at some point when the dipole insulator hits this, you won't be able to go any higher. I don't suggest you have the dipole insulator hit this because then you're so close to the guy wire. So what we're gonna do is we're going to, let me reset the camera. Okay. What I'm going to do is I'm going to pull this up. It got up on both ends. This same identical thing is happening on the other end. I'm going to pull this up, and then instead of a coax, I'm just going to hang a rope down from the center Ballon, and then we're going to measure that distance. So we're starting off with a 40-meter dipole, 66 feet, and we're going to pull that up. And with the dimensions I gave you before, this anchor being 100 feet from the base of the tower, and the distance between the two guy points as 185 feet, we'll be able to see how high this goes, how high you can raise a 40-meter dipole without leaving the ground. So, oh, the other thing you want to be sure of is that your pulley rides cleanly on the guy wire. Yeah, I know these have a lot of surface rust on them. This tower's almost 50 years old now. And that your rope stays firmly in this pulley. It's going to make the whole job a lot easier. All right, let me figure out what the next camera angle is, and I'll show you a little bit of the pulleys riding up. Okay, so that was kind of a trial run. I'm not sure how much of that you got, but whatever you did, you did. Over there is, oh yes, you'll notice that I have a bunch of cables that come down from the tower. That adds a little bit of complexity for me to do this, because I have to make sure I weave everything across the right way. So I'm going to leave this running for a few minutes as it goes up the guy wire, and then I'll shorten it up. Let's see, how high up can you see that? Oh, you can see up there quite a ways. I'll just leave this running, and I'll start the whole process of pulling the dipole up. And once I get it a little ways up, we'll stop, we'll measure the tape, see how far it's up, and we'll go from there. So again, it's just two simple pulleys. It's a lot of walking back and forth. Whoop, looks like my rope came off that pulley. I'm going to have to be careful about this. Looks like that rope came off. That's okay. I'm about halfway up on the other side. Let me go over towards the middle. Stand by. Okay, here's the Ballon as it clears this wire. I'll pull it up a little ways, and then I'll aim the camera at the tape measure and see how far we got. Oh, that's about as halfway as high as it'll go. Let's take a look at the tape measure. Right now it's 37 feet off the ground. Let me pull back a little more, and I'm going to go pull each side up. And am I recording? Yeah. Let's see. Can you see that? Yeah. 37 feet up. Let me pull a little bit more, reset the camera, and where I'm going to be headed right now is, let's see, can you see that anchor? No. All right, well, there's the Ballon. Let me start pulling it up a little further. It looks like we got quite a ways to go. Well, that's what happens when you don't tie off the other end really well. Be back in a minute. Going back out to the anchor. Okay, I'm going to tie this end off to the tower, and it looks like we are getting close to the maximum height here, but let me tie this off and take a look. Okay, let's see where we're at. Okay, we're at 47 feet. And the one end is about as high as it could go. Actually, that's not true. I'm going to balance it now. Here, I'll take the camera off. Let's see. Where's our footage? Here we go. 47 feet. That's the height of that dipole right now. I'm going to pop this off the camera, off the tripod. Okay. So, let's see if you can see that. Boy, I can't see it. Okay. Yep, that is as high as it could go. Oh no, it's not. Excuse me. There's the insulator there. So I have to let some wire off of the other side and pull this side farther up. So let's see what happens. Okay. Here we go. Straight on the ground, and total height achieved 61 feet. Went back and forth a lot of times, but you know what? This wasn't. There wasn't an awful lot of edits here as far as how much time it took to do this. Let's see if I stand. I guess if I stand back over here somewhere. I hope this came out. This is not meant to, you know, say pull a dipole up between your tower legs, I guess, or maybe it is. But just again, something to help people who want to put up a dipole like that. I don't really need a 40-meter dipole, but it was convenient. I had it there, and it was convenient, and I figured, what the hell? I'll show you how I did it. And when you're only one person and you don't have a lot of people to help you, it means you have to run around a little bit more, but at least you can get stuff done. So I'll try to show you some more shots with the tripod of close-ups of what the dipole looks like without shaking your brains out. Anyway, made it to 61 feet. 20-meter dipole would go even higher. A 6-meter dipole would go even higher. And an 80-meter dipole would go significantly lower because you're obviously, you know, the length of the dipole. So anyway, let me shut this off. Okay guys, here's what the assembly looks like in the real world up in the air. I think that's about 4 or 5 feet from the insulator to the pulley. So this could probably go up another 6 or 7 feet, but we got 67 feet or 61 feet out of it, which is a half wavelength, which should work pretty well as a DX. The other thing is there's nothing that says you can't lower this down to 30, 40, 50 feet, whatever you want to do to try different heights, right? Just have to have the right amount of rope available to you. I don't have a coax on this right now, just a tape measure. So I'm going to try to shoot across here, and we'll go over to the center of the antenna. Now, I'm going to zoom out, because the center of the antenna is, where is it? It's right to the right of the tower. Okay, so tripod really doesn't want to go up that high. But there's the other end of the center with the Ballon in place. And let me move the tripod. Okay, that's the other piece of wire connected through the other pulley coming up the guy wire. And I'll zoom in slowly, or as slowly as I can. So actually, it looks like I could pull this up another 5 feet or so. But I want to stay away from the guy wires themselves so that they don't influence it very much. Now here's another thing that you could do. Let me change angles. Okay, so there's the Ballon. You can see it hanging. You can probably see where the coax should be hanging off of it. The other thing that you could do here is just use a continuous piece of rope across, and you could hang a vertical dipole down. One antenna I did once, I pulled this wire much higher to the top of the tower, and I hung down 30 feet of wire, and I made a 40-meter ground plane, if you can picture that. And the coax hung straight below it and then went into the house. So just some ideas on how you can pull stuff up on a tower. There's a lot of guys with towers, a lot of guys don't have towers, but if you do, here's something that maybe you didn't think about. I hope you got some enjoyment out of this anyway. I certainly put a few miles on the old Fitbit here. Anyway, thanks a lot for watching, and when I go inside, I will do I'll show you on a tripod on the Group W bench what it is I'm doing, in case this doesn't make any sense. 73 for now. Thanks for watching, and please subscribe if you want to see more stuff like this. I got lots of weird ideas that are just rolling around in the old noggin waiting to come out. But this is one that I've used many times to pull up an experimental antenna. You could also pull up a VHF antenna. You know, grab it with an insulator at the top, say a vertical dipole for 2 meters, or a ground plane for 2 meters, or a scanner antenna, all sorts of stuff. Okay, that's it. Thank you for watching. This is W1VLF out in the North 40 signing off.